The Georgia Journeyman and Master Electrician exams are administered by the Georgia Electrical Contractors Licensing Board, or ECLB. The exams are in paper and pencil format, lasting 6 hours. The Journeyman Electrician exam covers several key areas. Firstly, electrical theory, which accounts for 25% of the exam. This section focuses on basic electricity, magnetism, and safety principles. Secondly, electrical code, also comprising 25%, tests knowledge of the National Electrical Code, or NEC, requirements for residential, commercial, and industrial installations. Thirdly, wiring methods and calculations. Another 25% covers conductors, conduit, wiring devices, and circuit calculations. Fourthly, equipment installation and maintenance makes up 15%, assessing knowledge of motors, transformers, lighting fixtures, and other electrical equipment. Fifthly, troubleshooting and repair accounts for 10%, focusing on common electrical faults and troubleshooting techniques. The Master Electrician exam includes all the content from the Journeyman exam, with additional advanced topics. Firstly, advanced electrical theory, which accounts for 10%. This section covers harmonics, power factor, and electrical system analysis. Secondly, project management and supervision, also at 10%, focuses on project documentation, scheduling, budgeting, and supervision. Thirdly, estimating and cost analysis, at 5%, covers material and labor estimating and project costing. Fourthly, code interpretation and enforcement, another 5%, assesses advanced knowledge of the NEC and code enforcement procedures. To prepare for the exams, firstly, study the National Electrical Code and relevant Georgia Electrical Code regulations. Secondly, attend exam preparation classes or workshops. Thirdly, review textbooks, study guides, and practice questions. Fourthly, get practical experience in electrical installation and maintenance. To register for the exams, firstly, apply through the ECLB website. Secondly, pay the application and exam fees. Thirdly, provide proof of experience and education, which is specifically required for the Master Electrician exam. The passing score for the Journeyman Electrician exam is 70%, while the passing score for the Master Electrician exam is 75%. For tips for success, firstly, start preparing early and study diligently. Secondly, understand the concepts behind the code requirements. Thirdly, practice solving circuit problems. Fourthly, familiarize yourself with common troubleshooting techniques. Fifthly, consider getting certified by a reputable organization such as the National Electrical Contractors Association, or NECA. Sixthly, stay updated on code changes and industry best practices. Electrical theory is fundamental to understanding how electrical systems work. It involves understanding concepts such as voltage, amperage, resistance, and power. Voltage is the electrical potential difference between 2 points in a circuit and is measured in volts. Amperage is the measure of electrical current flow and is measured in amps. Resistance is the opposition to current flow and is measured in ohms. Power is the rate at which electrical energy is transferred and is measured in watts. Ohm's law states that voltage equals current times resistance, or volts equals amps times ohms. This law is essential for calculating circuit parameters and solving electrical problems. Magnetism is closely related to electricity. When an electric current flows through a conductor, it creates a magnetic field around the conductor. Conversely, a changing magnetic field can induce an electric current in a conductor. This principle is used in many electrical devices, such as transformers and generators. Safety is paramount when working with electricity. Always follow safety procedures and wear appropriate personal protective equipment, or PPE, such as insulated gloves and safety glasses. Never work on live circuits unless absolutely necessary, and always use lockout/tagout procedures to de-energize circuits before working on them. The National Electrical Code, or NEC, is a comprehensive set of standards for electrical installations in the United States. It is updated every 3 years and provides detailed requirements for the safe installation of electrical systems. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. Understanding the NEC is essential for passing the electrician exams and for working safely and effectively as an electrician. The NEC is organized into chapters, articles, and sections. Each section provides specific requirements for different types of electrical installations. For example, Article 210 covers branch circuits, Article 250 covers grounding and bonding, and Article 300 covers wiring methods. It is important to be familiar with the structure of the NEC and to be able to quickly find the relevant sections for a particular installation. Residential installations have specific requirements in the NEC. These requirements are designed to ensure the safety of occupants and to prevent electrical hazards. Some common residential wiring requirements include the use of arc fault circuit interrupters, or size, in branch circuits supplying bedrooms, living rooms, and other areas, and the use of ground fault circuit interrupters, or GFCIs, in bathrooms, kitchens, and outdoor areas. Commercial installations also have specific requirements in the NEC. These requirements are often more complex than those for residential installations due to the larger size and greater complexity of commercial electrical systems. Some common commercial wiring requirements include the use of metal conduit for wiring, the installation of emergency lighting systems, and the use of separate circuits for different types of equipment. Industrial installations have the most stringent requirements in the NEC. These requirements are designed to protect workers and equipment from electrical hazards in industrial environments. Some common industrial wiring requirements include the use of explosion-proof equipment in hazardous locations, the installation of grounding systems to prevent static electricity buildup, and the use of dedicated circuits for critical equipment. Wiring methods refer to the ways in which electrical conductors are installed and protected. The NEC specifies various wiring methods that are acceptable for different types of installations. Some common wiring methods include rigid metal conduit, or RMC, intermediate metal conduit, or IMC, electrical metallic tubing, or INT, flexible metal conduit, or FMC, and non-metallic sheathed cable, or NN cable. Conductors are the wires that carry electrical current. The NEC specifies the types of conductors that are acceptable for different applications. Conductors are typically made of copper or aluminum and are insulated to prevent electrical shock. The size of the conductor is determined by the amount of current it needs to carry. Conduit is a protective enclosure for electrical conductors. It is typically made of metal or plastic and is used to protect conductors from physical damage and environmental factors. The NEC specifies the types of conduit that are acceptable for different applications. Wiring devices are components that are used to connect electrical conductors, such as switches, receptacles, and terminals. The NEC specifies the types of wiring devices that are acceptable for different applications. Circuit calculations are essential for determining the correct size of conductors, overcurrent protection devices, and other components in an electrical circuit. The NEC provides guidelines for calculating circuit parameters, such as voltage drop, ampacity, and short-circuit current. Motors are used to convert electrical energy into mechanical energy. The NEC specifies requirements for the installation and protection of motors. These requirements include the use of motor overload protection, motor disconnecting means, and motor grounding. Transformers are used to change voltage levels in electrical systems. The NEC specifies requirements for the installation and protection of transformers. These requirements include the use of transformer overcurrent protection, transformer grounding, and transformer ventilation. Lighting fixtures are used to provide illumination. The NEC specifies requirements for the installation and protection of lighting fixtures. These requirements include the use of proper wiring methods, fixture supports, and lamp protection. Other electrical equipment includes a wide range of devices such as heating equipment, air conditioning equipment, and industrial machinery. The NEC specifies requirements for the installation and protection of this equipment. Troubleshooting is the process of identifying and resolving problems in electrical systems. It requires a systematic approach and a thorough understanding of electrical principles. Common electrical faults include open circuits, short circuits, ground faults, and voltage drops. Troubleshooting techniques include using a multimeter to measure voltage, current, and resistance, using a circuit tracer to locate wiring, and using a visual inspection to identify damaged components. Advanced electrical theory includes topics such as harmonics, power factor, and electrical system analysis. Harmonics are distortions in the voltage and current waveforms that can cause problems in electrical systems. Power factor is a measure of how effectively electrical power is being used. Electrical system analysis involves using mathematical techniques to analyze the behavior of electrical systems. Project management involves planning, organizing, and controlling resources to achieve specific goals. In the context of electrical projects, project management includes tasks such as developing project schedules, managing budgets, and coordinating with other trades. Supervision involves overseeing the work of others to ensure that it is done correctly and safely. In the context of electrical projects, supervision includes tasks such as providing training, monitoring progress, and enforcing safety regulations. Estimating involves determining the cost of materials and labor for a project. Cost analysis involves evaluating the costs of different project options to determine the most cost-effective approach. Code interpretation involves understanding the meaning and intent of the NEC and other electrical codes. Code enforcement involves ensuring that electrical installations comply with applicable codes. Exam preparation is essential for passing the electrician exams. It involves studying the NEC, reviewing textbooks, and practicing solving circuit problems. Attending exam preparation classes or workshops can also be helpful. Exam registration involves applying through the website and paying the application and exam fees. Proof of experience and education is required for the Master Electrician exam. To improve your chances of success, firstly, start preparing early and study diligently. Secondly, understand the concepts behind the code requirements. Thirdly, practice solving circuit problems. Fourthly, familiarize yourself with common troubleshooting techniques. Fifthly, consider getting certified by a reputable organization such as the National Electrical Contractors Association or NECA. Sixthly, stay updated on code changes and industry best practices. Remember to always prioritize safety when working with electricity. The NEC provides the standards and guidelines for safe electrical installations, and understanding these requirements is critical for success in the electrical field. Continuously update your knowledge and skills to stay current with the latest technologies and best practices. The Georgia Electrician exams are challenging, but with diligent preparation and a solid understanding of electrical theory and the NEC, you can achieve your goal of becoming a licensed electrician. Good luck.